Okay, we finally reached our last two topics in the appendix. We've been jumping around sections, we've been jumping around topics, and we're finishing with this fourth section. So much of what we do in math is the four main operations: addition, subtraction, division, multiplication, but we do those in different number systems. So we've done complex number stuff a little bit in this class, a lot more in Algebra 2. We'll do some more later. We've done rationals. You've added them, you've subtracted them, you've divided them, you've multiplied them. Now we're going to do polynomials. We've already done addition, subtraction. We've done multiplication. That's all the double distributing stuff. Now we're doing the last thing in division. So there's a long way. That's polynomial division. That's called long division. And there's synthetic division, which is a shortcut, but you can only use it in with certain properties. So this whole idea goes back to what you guys did in grade school. If you had a problem like this, you'd be like, oh, well, 21 doesn't go into 4, so I'm not going to put anything there. 21 goes into 43, though, twice, and then you multiplied this down. Now you flipped the signs, and you said there's 1 left over. Keep that in mind when we do this polynomial stuff, because that's going to be super helpful. Now, you say, okay, you bring down the 12. 21 doesn't go into 12, so I'll put a 0 up here. This then becomes your remainder. And your answer is, well, it goes in 20 times with a remainder of 12. But think about what you're really doing. You're saying that 432 is the same thing as 21 times 20 adding on 12. This times this plus your remainder is your original. It's going to be the same idea for polynomial division. So let's take something like this. Find the quotient. How many times does it go in the remainder when you take this cubic polynomial and you divide it by 2x squared minus 1. You set it up exactly the same as you guys have been doing before. Now, here's what we do. Ignore the minus 1. We'll come back to that. Focus on this, the 2x squared piece. What are you going to have to multiply by up here that when you multiply, you get 2x cubed? The number's taken care of. We're just 1x short. So then this gets multiplied both places here and becomes 2x cubed. You want these to match up perfectly because we're going to flip and add. Now, the x also gets multiplied by that negative 1, and that becomes minus x. So it's important that you line it up underneath the x, not the x squared, because all the rules about like terms still apply. So now flip this. Those cancel, which is exactly what we want. This gets dropped down. This comes out to 2x. We might as well go ahead and drop the minus 4 down now as well. So now, how do you get 2x squared up to minus 8x squared? Well, how about a minus 4? And it's okay, you don't have to worry about putting this minus 4 a certain place here on kind of your division line. You can just kind of put it anywhere up top. That's one nice thing. Now, this gets multiplied both places. So minus 8x squared, it matches up perfectly, and plus 4. Flip both signs and add. So if you want to use different colors, colored pencils, that might be a good idea. Okay. Now, there's no way you're going to get a 2x squared down to a 2x. So your quotient is x minus 4. Your remainder is 2x minus 8. And that's what I'm looking for your answer. Now, just like we could go double check our answer back here doing this, you can do the exact same thing with polynomial division. So basically what you just said is 2x minus 1 times an x minus 4, adding on your remainder, should be this piece under here. So if we double distribute this, we collect all our like terms. It matches up exactly. So you can check your answer. You could also use the calculator. I'll show you that in a little bit. But this is what I'm looking for right here. Quotient, remainder. Just like a lot of stuff we've done this unit, if you take the time and check your answer, you can see if you got it right. Okay, let's try another one. So we'll set this up the same way. So now, how do you get a 2x squared to be a 6x cubed? Let's try a 3x. So we multiply. So 6x cubed plus the 3x needs to go over here so it stays under the term it belongs to. Flip the signs and add. Those cancel. This drops down. This goes to minus 2x. Okay, how do we get a 5x squared to a 2x squared up to a 10x squared? How about just a plus 5? So this gets multiplied both places. So we'll get 10x squared. Let's go ahead and drop the 8 down now. And plus 5. Flip the signs and add. Those cancel. We'll drop down to minus 2x, and this goes to plus 3. There's no way you're going to get a 2x squared to a negative 2x. You can't make it go down powers, so there's your remainder. So your answer, there's your quotient with the remainder of negative 2x plus 3. Okay, I'm going to pause this real quick and set up how we're going to double check our answer. Okay, so again, our quotient times our divisor plus the remainder should equal the original. I did all the double distributing there and it matches up. Now, one last example with long division. And this one's a little bit different because if you look at this fifth power polynomial here, it goes 5, 4, 2, constant. Now, think back to when you did long division by hand with numbers, you always had to hold the decimal places. Okay, if you didn't, you ended up with terms and no place that they really belonged. So what I have to do is I have to create placeholders. So 0x cubed. I also have to create a 0x. Or else, when I start putting things up here and distributing them, you may find you don't have places for them to go. Okay, it's easy to forget the 0x one because you see the x squared and the constant, but just make sure you go 5, 4, 3, 2, 1, constant. Okay, you have to have every one there. And this also, you have to do the same in synthetic division. So now let's repeat this process again. How do I get an x cubed up to an x to the fifth? So we'll distribute these. So x to the fifth. Now, this is why you have to hold those places. Where are you going to put a 3x squared if you don't have any place for it? Okay, flip signs and add. Those cancel. It's exactly what we want. This drops down. This goes to 3x cubed. So now I need to get an x squared to a negative 2x to the fourth. So how about minus 2x squared? Distribute both of these. It'll give me minus 2x to the fourth and plus 6x squared. So I'm going to go ahead and I'm going to drop this down so it actually has a place to go. Flip your signs and add. So this swings down, this becomes positive x squared. I'm going to go ahead and bring down the 0x. It's more just play around with enough of these and you kind of figure out when to bring them down, or you can always worry about them later. So how about a plus 3? This gets distributed, so this becomes 3x cubed. Oops, we're going to need a 3x there, so we actually get it up to an x cubed. So plus 3x cubed on the second distribution minus 9x. Okay, flip your signs and add. Those will cancel. This drops down to an x squared plus 9x. I'm going to go ahead and bring this minus 5 down. Okay. Now I need to get an x squared to an x squared. How about just a plus 1? So distribute that, and you get an x squared minus 3. Flip your signs and add. You're left over with a 9x minus 2. So your answer becomes x cubed minus 2x squared plus 3x plus 1 with a remainder of 9x minus 2. Now, if you wanted to check your answer, you'd have to take this here, double distribute it here, add on your remainder down here. Now we can use technology to help us out a little bit with that, and I'm going to pause you guys and meet you with the calculator. Okay, so what I did here is, if we think this is our answer, like I said, we should take this, double distribute it here, add a remainder, and we should get the original. So that's what I did. I just used the technology and wrote it as polynomials. So this right here, parentheses, multiplied by an x squared minus 3, add on my remainder, and then I went and plugged in the original, x to the 5th minus 2x to the 4th plus 7x squared minus 5. No need to put those placeholders in there. You go to the table, you get the same numbers, you know you did it right. So there's an easier way to kind of check your answer for those longer problems. Okay, there's your recap of long division. I'll meet you guys in part 2 for synthetic division.